Okay, guys, so let's talk about the graphs of sine and sine of 2x. So this is a k value, right? So firstly, tell me what happens when I create a k value or when I put a k value transformation in of 2. What does that do to my graph? What's the transformation? Bella? Horizontal compression by a half, right? I compress it by the reciprocal of k. Okay, so we can see that what was once in between, it was one cycle in between 0 to 2 pi, is now 2 cycles in between 0 and 2 pi because I've taken that and I've compressed it by a half. So I've put double the amount of cycles in between 0 and 2 pi. That's the idea. So this is going to help us kind of understand what we're doing today. So what is the period of both functions above? Well, the period of sine x, I can see it starts at 0. And a full mountain and a full valley, one cycle, goes from 0 to 2 pi. So the period of this one is 2 pi. And how many cycles in between 0 and 2 pi? There is one cycle from 0 to 2 pi. For sine of 2x, what did you guys come up with for the period of this one? Pi. So one full mountain and one full valley here happens between 0 and pi. And how many cycles do we see in between 0 and 2 pi? Okay, so there's 2 cycles. So as I said, because we have compressed this by a factor of a half, now there's double the amount of cycles inside 0 to 2 pi. I know, right? Okay, so the next question then asks you, if I look at the graph and I try to see where sine x is equal to approximately 0.71, how many times is that happening in between 0 and 2 pi? So 0.71, this is 0.75. So 0.71 is like, kind of like here, just before 0.75. So I can see it's happening once here. It also happens once on the way down. It happens once here. And I'm just cutting it off there, in between 0 and 2 pi. So sine hits a y value of 0.71 twice in between 0 and 2 pi, right? Once here and once here. Okay, so there are 2 solutions in between 0 and 2 pi. How many are there in between 0 and 2 pi for the graph of sine of 2x? Let's take a look. So in between here and here, how many times do I hit that like 0.71 value? I hit it once here, once here, yes, once here, and once here. I hit it 4 times. Okay, so there are 4 solutions. So when the period of the function is cut in half, the number of solutions doubles because now I have 2 times the amount of cycles in there. Okay, so the number of solutions doubles. What if my k value was 3? What would we suppose happens to the number of solutions if I compress by a factor of 1/3? I'll have 3 times as many solutions. Perfect. Okay, so depending on what I have in here, that's going to help me understand how many solutions I should be looking for, right? If I have a 2 in there, I'd be looking for double the amount of solutions as what I would have for when I just have an x. If I have a 3x in there, I'll have triple the amount of solutions. If I have a 4x, I'll have quadruple the amount of solutions, and so on. Because I have more cycles in between 0 and 2 pi. So that's the idea. Okay, so we're going to use that in our solving today. So we are solving, these are called double angle expressions. So they're linear trig expressions, but they have a double, like a 2 times theta inside here instead of just a theta. So we will solve these similar to how we've been solving our linear trig equations, but then we have to consider that we've also changed the period of the function as well, so there might be more solutions. So what I like to do in these questions is I like to just start with a little let statement. we're going to do a let statement. So we're going to let 2 theta equal something. Doesn't matter what you put, some variable. If you'd like to make it x, that's fine. Usually I just use x. So I want to just start by solving this. And we're going to have to remember at the end that we need to consider this let statement once we've solved. But we're going to start by solving this. Do we know how to solve something like this? We definitely do. Let's go through the decision process. So decision process. Can I use a graph for this? Yes or no? No, it's sine, but it's not equal to 0, 1, or negative 1. Could I get an opposite over hypotenuse of 1 over 2 from a special triangle? Yes. Which one? Okay. So then we just have to decide, would pi over 6 or pi over 3 give us an opposite over hypotenuse of 1 over 2? Okay, pi over 6 will give us an opposite over hypotenuse of 1 over 2. So pi over 6 will be our reference angle. So I'm solving this as we would usually solve this. There'll be something at the end that we'll have to do to take care of this, though. Okay, so sine is equal to a positive ratio. Where would I expect my answers to fall? I heard it over there somewhere. Was that you, Serena? Bella? 1 and 2, all in sine, with a reference angle of pi over 6 for both. So what's my first x? It's just pi over 6, right? It's just this rotation right here. So x1 equals pi over 6. How about x2? How do I calculate this one? I want this rotation right here. Pi minus the reference angle. So x2 will be pi minus pi over 6. Common denominator, and subtract. We get 5 pi over 6. And these are radians. But we did a let statement, right? So we have to consider the let statement here. And the let statement says that 2 theta is equal to x. And my goal in all of these is we want to solve for theta. So solve for theta. So if 2 theta is equal to x, what is just theta equal to? One over x? X over 2. I just divide out the 2, right? Okay, so here's both of my x's. I need to sub them back into this statement here. So if theta equals x over 2, I would do pi over 6 divided by 2. And then when I flip and multiply, I'm not going to show this every time, but when I flip and multiply, I do 6 times 2, which will give me pi over 12 radians. So that's theta number 1. I should have probably done that in red to match the red one, but oh well. Theta number 2 is going to come from x number 2, and I'm going to sub it into my let statement that we've just rearranged here, which is 5 pi over 6 divided by 2. Okay, when you flip and multiply, as we did above, you're going to get 5 pi over 12 radians. These are our first 2 answers. But we know if we solve something like this and we get 2 answers, when I do sine of 2 theta, I should expect double the amount of answers, right? Okay, so if we think about the sine of 2 theta, the period of this function is 2 pi over the k value, which our k value is 2. Well, this is our formula from last unit, and you also told me above, because we were looking at sine of 2x here, right? And sine the period was pi. Okay, but period we can always calculate by doing 2 pi over k. And this is the k value, right? It's the multiple of theta. Okay, so if my period's pi, and I've taken this and I've compressed it horizontally by a factor of 2, or a factor of a half, I should say, I should expect double the amount of answers, right? As something like sine of theta. So I got 2 answers to the linear trig equation above, and I have 2 answers to sine of 2 theta, but I need the 2 other ones. So we found the first 2 in the first cycle. We found that this answer and this answer, where sine is equal to 1 over 2, I want now this answer and this answer. So what do I know about the distance from here to the corresponding point on the next cycle? How far away would those 2 corresponding points on each cycle be? Bella? Why pi? So any 2 corresponding points on a cycle are always the period length away from one another. So if I want to find the second answer in the second cycle, I need to add the period to that. And I know the period is pi. So I'm going to find that second answer by taking my x1, or my theta 1, and I'm going to add pi to it. And I'll find theta 3. This will be the third possible answer. So I'm going to take the first answer and add the period, always. And I should get pi over 2 plus the period, which is pi. Common denominator, pi over 12 plus 12 pi over 12 gives me 13 pi over 12 radians. Is this still below, is this still in the range of 0 to 2 pi? 13 pi over 12. It needs to be less than 24 pi over 12. 24 pi over 12 equals 2 pi, right? So 13 pi over 12 is still less than 2 pi, right? Because my question tells me that theta has to fall between 0 and 2 pi. It needs to fall in the first rotation. Okay, so this is still a valid answer. Any guesses to how we can find the fourth theta here, where sine is equal to 0.5? Look on your graph. I want now this answer. How far away will these be? These 2 corresponding points. They will also be the period length away. They'll be pi length away. So I'm going to add the period to my second answer here. So I'll take my second answer. I'll have 5 pi over 12 plus the period, which will be pi. And then I can do 5 pi over 12 plus 12 pi over 12. And that's 17 pi over 12 radians. Is that still less than 2 pi? 2 pi is like 24 pi over 12. You can calculate the decimal value. 2 pi is like 6.28. This is still less than that if you calculate the value. Serena? So I take it from my answer in the first cycle, and I just add the period to it.
But for these types of questions, like when we're looking at graph method, are we supposed to assume that the period is pi?
So you can find the period because you will know the k value, and the period is always 2 pi over k. That's from last unit when we were doing all the graphs and stuff.
How do you know that 2 is the k?
Well, if I have a times sine k, let's say theta minus d plus c, k is the multiple that's inside the brackets. So I know that this must be a k value, right? It's not an addition or subtraction, and it's not outside like an a value would be. Kenzie? Sorry, can you say that a bit louder? Well, that wouldn't be in the valid range. Like, I could keep getting more answers where sine is equal to a half, but the question tells me the specific range of values that I want. I want it to be in between 0 and 2 pi. So then I wouldn't go any further because the more answers I try to solve for, they'll be out of the first rotation's range.
Will you ever ask us to look at it?
No. How can I check my answer? Let's do a check. My original question is, I want to find where sine of 2 theta equals positive 1 over 2. Michael? Yep. So let's plug in all the thetas. Sine of 2 times pi over 12. You can just check it right on your calculator. Then you're going to check sine of 2 times 5 pi over 12. Make sure that's positive half. Then we'll check sine of 2 times 13 pi over 12. Make sure that's a half. And then you'll check on your calculator, make sure you're in radians. Sine of 2 times 17 pi over 12. Okay, so if I've done this correctly, they should all give me positive 0.5 out in my calculator, positive half. So these do all give us positive half. Make sure you know how to check your own answers. So that's a yes, 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 yes. So we're good for all of our answers. Okay, we're going to try another one just so we can kind of get the hang of it, okay? All right, so very similar. This time we're going to do cosine. We can do any of the trig ratios, okay? It won't always be from a special triangle. It could be from a graph. We might also have to use our calculator to solve for it, just like we do with any other linear trig equations. Okay, so if I have a k value of 2, what does this do to the number of answers compared to cos x or cos theta? Okay, so we will have double the amount of answers. If this was 3, we would have triple the amount of answers. And we might as well just quickly, can we find the period? If k is 2, then I do 2 pi over k. And I think the period should be the same as the other one, right? Because k is 2 in this one, and k is 2 in the other one. So we get a period of pi. So in between 0 and 2 pi, we'll get double the amount of answers that I would get for something like cos of theta equals negative root 3 over 2. All right, we're going to do a little let statement. Let's let 2 theta equal x, just to simplify this a little bit for ourselves. And I'm just going to start by solving for where cos x equals negative root 3 over 2, which we know how to do. Okay, we did things like this for our warm-up question and for our quiz today. Okay, always decision process, guys, because if we can leave these in exact values, then we're going to. So our decision process is, can I use a graph for this? That would be a no. It is cos, but it's not equal to 0, 1, or negative 1. Could I get an adjacent over a hypotenuse of root 3 over 2 from a special triangle? Yes. If not, you use your calculator and you can use decimals for the remainder of the answer. But if you answer yes to either 1 or 2, then you're going to be using exact values for all your answers. Okay, so this is going to come from that same triangle that we actually used for the previous question, pi over 6, pi over 3 triangle. And which angle, pi over 6 or pi over 3, is going to give us an adjacent over a hypotenuse of root 3 over 2? What makes this adjacent? Pi over 6. Okay, so our reference angle will be pi over 6. And I need to consider the quadrants where cosine is going to give us out a negative ratio because cosine is equal to negative root 3 over 2. So in which quadrants would I expect my answers to fall? 2 and 3, sine and tan. Okay, put them in. Reference angle is always between your angle and the closest horizontal. So our reference angle will be here and inside here, pi over 6 and pi over 6. Let's call this x1 and x2. How do I solve when my answer is in quadrant 2? I want just this rotation right here, up to that arm. Serena?
You do
Pi minus the reference angle, perfect. So 6 pi over 6 minus pi over 6 gives us 5 pi over 6 radians. x2, I want this rotation all the way around and to this arm. How do we calculate that one? It will be a full pi plus an extra pi over 6. So pi plus the reference angle, pi over 6. So 6 pi over 6 plus 1 pi over 6 is 7 pi over 6. The let statement is the important part of this, right? Because we now need to use our x's and we need to sub them back into the let statement. So sub back into your let statement.
Don't we have to find the other?
We'll do that after we find the first two thetas. So if 2 pi, or sorry, not 2 pi, if 2 theta equals x, then if I divide out the x, theta equals x over 2. So theta 1, we're going to get from x1. Theta 1 will be equal to x1, which is 5 pi over 6, divided by 2. Five pi over 6 divided by 2, flip and multiply, it's 5 pi over 12 radians for the first one. Theta 2, we're going to get from x2. So I'm going to take this, plug it right in here. 7 pi over 6, divide by 2. I'll get 7 pi over 12 radians. Now, as we stated above, we would expect to get double the amount of answers that we get in this first part. So if I got 2 answers when I did my let statement, how many answers should I expect to get for the second part? 4. Okay. Sometimes, for instance, if I choose maybe graph as a possible method, sometimes there's only one answer when I use a graph. Like for instance, where sine equals 1, I only have one answer. So then I'll just have double the amount of answers down here, which would be 2 answers. So just keep that in mind. Okay, so we found the period above. What was the period again? No. Period was pi. So to find our next 2 answers, theta 3, we're going to take theta 1 and add the period. Okay, because we know every period that happens, those values are all going to have the same y values. That's the nature of a periodic function. So theta 3 will be equal to 5 pi over 12 plus the period, which is pi. So 5 pi over 12 plus 12 pi over 12 gives us 17 pi over 12 radians. And theta 4, I'm going to take theta 2 and add the period to it. 7 pi over 12 plus, I'm just going to create that common denominator right now, 12 pi over 12. And that will give us 19 pi over 12. Is this still less than 2 pi? Are both of these less than 2 pi? 2 pi is equivalent to 24 over 12, 24 pi over 12, so we're good. We're still in the range between 0 and 2 pi. Perfect. Those are our answers. Sometimes you will have decimal answers if you have to use your calculator, if you go through the decision process and you have to use your calculator. Okay, quick check for these. I want to check that cos of 2 times each of these angles gives me out the same decimal as negative root 3 over 2. So you're going to check each of these by plugging them back in. Make sure your calculator's in radians, of course. And you may, if your calculator doesn't leave things in exact values, you may need to just calculate what approximately negative root 3 over 2 is equal to. So if I plug that into my calculator here, negative root 3 over 2, oops, is like negative 0.866. So that's what I would expect to get out for all of these if I put them into cosine. Okay? Or some of your calculators will literally just spit out 0, like negative root 3 over 2. Depends on the type of calculator you want. But all of these are equal to approximately negative root 3 over 2. So we're good for each of those when we plug them in. Okay, don't take my word for it. Check it on your own calculator so that you know how to do your own checks. Okay? Questions? Serena?
Could you just explain how we know that the period is pi? Like, the graph?
So we'll do a calculation. So period is always found with 2 pi over k. And this is our k value. So you can find the period if you don't have a graph as long as you have the equation. Rebecca? They all have to equal the original statement here of negative root 3 over 2. So if you plug negative root 3 over 2 into your calculator, that's about negative 0.866. So those. Okay, anything else? So if I had a 3 here, and I got 2 answers here, I would expect to get 6 answers down here, right? So I calculate my period, and then I add the period, and I keep adding the period until I get my 6 answers. All right, so you guys have some time to practice today.